In this video, we will be replacing the rear brake pads in this 2008 Hyundai Elantra. For this repair, I'm going to be placing wheel chocks in front of and behind the front tire. We want to raise the vehicle until the tires are 1 inch off the ground and install safety stands. Once in place, I like to give the car a little shake just to make sure that it is seated correctly on the safety stands and the car is not going to shift or slide off of them. And your rear tire should rotate freely. Next, we can remove the rear tire. We're going to be removing the lug nuts in a star-shaped pattern rather than going around in a circle. This will evenly reduce the pressure that is on the wheel assembly. Although you can do this with a tire iron, an impact gun makes quick work of removing the tire. And a little persuasion will help remove the tire. After removing the wheel, we have uncovered the rotor, which is the large disc type object that we see. This is a hat type rotor because the center portion sticks out quite a bit beyond the rotor itself. Our emergency brake components are underneath the hat portion of this rotor. We also have our brake caliper assembly, and underneath here we have our brake pads. Taking a closer look at the brake caliper assembly, we can see the caliper itself. We can see the brake caliper mounting bracket, and we can also see our brake line that is connected to our caliper. There is also a view hole located on the back of the caliper. This allows us to do a quick inspection of the thickness of the brake pads. Based upon our limited view through the view hole, it appears as though there is quite a bit of brake pad material left on this vehicle. Typically, if the brake pad thickness is the same as the backing plate, it is said that there is about 50% left. Because these brake pads are significantly thicker than the backing plate, it is estimated that there is well over 50% left on these brake pads. Now, it is worth noting that there is over 81,000 miles on the vehicle, and these are the original brake pads. This puts the brake pads at about 10 years old, and it is possible that as we remove the caliper, we will see greater wear on the brake pads. Returning our attention back to our caliper, we need to remove this to give us access to the brake pads. There are 2 caliper bolts which are connected to the caliper mounting bracket. These 2 bolts need to be removed. Now, because there is 81,000 miles and about 10 years on this vehicle, there's a good chance that these bolts are corroded or rusted in there. It is always good to place a drip pan underneath our brake system, as we will be spraying some various fluids onto the brake components. I'm going to be using some AMSOIL's metal protector as a penetrating oil to lubricate the bolts prior to removal. This product does an excellent job of loosening rusty bolts and breaking up corrosion on various parts. After that metal protector has soaked in, I'm going to be using a 14mm wrench. to loosen both caliper bolts. And then they can be removed. With the caliper bolts removed, we can pivot our caliper off of the caliper mounting bracket. This will give us access to the brake pads below. Our caliper is connected to our vehicle via a brake line. The brake line is flexible and can rupture if we are not very careful. If the caliper were to fall off, it would be dangling from the brake line, putting unnecessary stress on that brake line. What I'm going to do is take a coat hanger and I'm going to create a bracket to hold our caliper. And I'm going to wrap that around one of my other components. This way the caliper is not going to fall and pull on that brake line. Shifting our attention back to our brake pads, we can see that there is quite a bit more wear than we had initially thought by just looking through that view hole. We can remove those brake pads by pivoting them out of the brake pad mounting hardware. Taking a look at our old brake pads compared to our new brake pads, it is clearly evident that the old brake pads have had a substantial amount of wear. Specifically looking at our outside brake pad, we can see that the pad thickness is slightly thinner than the backing plate. This would indicate that there might be 35 to 40% left on these brakes. Turning back to our caliper mounting bracket, I'm going to remove the brake parts hardware, which will get us one step closer to removing the rotor. Now we need to still remove the caliper mounting bracket so we can gain access to the rotor and pull that off. There are two bolts on the back side of the caliper mounting bracket that is holding it onto the vehicle. The uppermost bolt has full access, whereas the lower bolt has an obstruction. If we look a little bit closer to that lower bolt, we can see that we will not be able to get a wrench or socket on there. I am again going to be using AMSOIL's metal protector to aid in the removal of these bolts. Using a 14mm wrench, I'm going to loosen the top bolt. We will need to remove the rear lateral arm to gain access to this last bolt to remove our caliper mounting bracket. To do this, we will coat our mounting bolt with AMSOIL's metal protector, and using two 17mm combination wrenches, we will loosen our mounting bolt. And using a rubber mallet, I'm going to work that bolt back. And then finish pushing that through with a nut driver. And then again, I'm going to use my rubber mallet to remove the rear lateral arm. This should allow me enough access to get to my last bolt that is holding my caliper mounting bracket. While holding that rear lateral arm down slightly, I can slip on a 14 millimeter deep socket. This rotor has 2 Phillips head screws that were installed on the assembly line at the factory to hold these components on. We need to remove these 2 screws next. After those screws have been removed, I'm going to remove the dust boot. And I'm going to use AMSOIL's metal protector around every lug, the screw hole locations, the dust boot, the center hub, and additionally inside the back of the rotor. Now this will need to be cleaned off later so it does not impede the braking ability of our brake components. Using a rubber mallet, I'm going to work my way around the rotor from the front side and the back side until that rotor comes off. If the rotor does not come off, as this one did not, we need to adjust the star wheel on the parking brake. To do this, we're going to locate our access port. We're going to position it at the 6 o'clock position towards the bottom. We will be adjusting the star wheel, and this is what it looks like with everything removed. When you do this, you want to start with the screwdriver tip towards the bottom and rotate the star wheel upward. This will pull the brake pads away from the rotor. After that, we can use our rubber mallet to work our rotor off. Now that our rotor has been removed, we can take a look at all of our emergency brake system components. Specifically, I am looking at the pad thickness of the emergency brake shoes. I am also just doing a visual inspection of all of the other components. If there is a high amount of corrosion, rust, or broken pieces or parts, you will definitely want to replace them. All of these components look to be in excellent condition, so we're just going to do a thorough cleaning of all of the emergency brake components and proceed with our repair. Using a rotor caliper, I want to check the thickness of the rotors. I'm going to cross-reference this with the discard thickness to see if we have enough material left on the rotor that we can just have these turned down instead of having to buy all new rotors. These rotors measure 0.394 inches. To find the discard thickness, I'm going to log on to O'Reilly Auto Parts. I'm going to search for rotor, and I'm going to select my vehicle, which is a 2008 Hyundai Elantra. And this is for the rear of the vehicle. There's a couple options here. I'm going to select the first one, and I'm going to scroll down and show all of the details. And we can see that the website provides us with a discard thickness. In this case, it is 0.331 inches. After having the rotors turned down, we are sitting at 0.376 for our driver's side and 0.376 for our passenger side. Prior to installation of our components, I will be using AMSOIL's brake and parts cleaner to clean all of the components of the parking brake system. This is a professional strength product. It is a chlorinated formula, and it does an excellent job cleaning all of the various components. After that, we need to clean both sides of our rotor with AMSOIL's brake and parts cleaner. And then we can reinstall the rotor. When installing our hold down screws, make sure you start them by hand first. We are going to adjust our star wheel until we can feel a slight drag on the rotor. And then we're going to back off that star wheel just a little bit. You can hear and feel a slight drag, so we're going to back this off just a little bit. And then we can reinstall that dust boot. Prior to installing the caliper mounting bracket, I'm going to use some AMSOIL's brake and parts cleaner and a wire brush, and I'm going to clean all of the surfaces as best as I can to remove any buildup. Prior to installing the caliper mounting bracket bolts, I will coat the threads in AMSOIL's heavy duty metal protector. This will prevent further corrosion in the future and allow me to service this down the road much easier. After that, I can reinstall my rear lateral arm. To ensure my bolt hole location gets lined up perfectly, I'm going to gently raise the wheel assembly and pull on my rotor until my hole location is lined up, and then work that bolt in there. And again, I'm going to use a little heavy duty metal protector by AMSOIL. And a little more brake and parts cleaner for where I touch the rotor. Our brake pads came with a hardware kit, so we will not be using the old hardware in this installation. Our brake hardware components fit onto the caliper mounting bracket around the rotor. Our brake pads can be installed next. However, there are two different types of brake pads. One of these has a wear indicator built into the brake pads. We want to make sure that the wear indicator brake pad goes towards the inside of the vehicle. The brake pad without the wear indicator goes towards the outside of the vehicle. After that, a little more brake and parts cleaner. The next component to install is the caliper. However, prior to installing the caliper, we need to reset the caliper piston. The caliper piston is located towards the center of the caliper. As the brake pads wear, the caliper piston will move out. This compensates for the thinning of the brake pad linings. Because we're installing new brake pads that are much thicker, we need to reset the caliper piston by pushing that back in. Prior to resetting the caliper piston, we want to take a look under the hood and find our master cylinder. On this particular vehicle, it is located towards the driver's side behind the airbox. The master cylinder has a translucent reservoir with a black lid. As I take a look at the fluid level, by wiggling the master cylinder reservoir, I can see that our brake fluid is already at the maximum level. If we reset this piston, we are pushing brake fluid back through the line into the brake fluid reservoir. This could cause the reservoir to overflow onto the engine. I'm going to be using AMSOIL's oil analysis pump with a section of replacement hose and an old bottle. This will allow me to suction out some of the excess brake fluid. To reset the piston, I'm first going to place an old brake pad in front of the piston. Next, I'm going to place a C-clamp or some type of hand clamp around the caliper with the brake pad. And as I close that clamp, it will slowly depress the piston back into the caliper. Now this is pushing brake fluid back through all of the lines into the master cylinder. Our caliper piston has now been reset and should have plenty of space for those new brake pads. And then our caliper can slip back on. A little heavy-duty metal protector on the threads and reinstallation. And I'm going to give both sides one more shot of brake and parts cleaner before I put the wheel back on. After that, we can reinstall our wheel. We want to make sure we start all of the lug nuts by hand first. And we also want to go in a star-shaped pattern when we torque these back down. This will give an even tightness as we're going around. At this point, we are ready to lower the vehicle down. However, we're not done quite yet. There are still two critical components that we need to do before we are ready to test drive. The first critical task is to refill the master cylinder reservoir. If you remember, we took out some of the fluid to allow the compensation of depressing the piston in, which pushes that fluid back into the master cylinder. However, our master cylinder is low, so we need to add more brake fluid. Identified on the top of the cap of our brake fluid reservoir, it tells us that we can use either .3 or .4 brake fluid. I'm going to be using AMSOIL's synthetic brake fluid, which meets the specifications for this vehicle. And I'm going to be filling this up to the max level. And make sure you put the cap back on. The second critical task is to depress the brake pedal multiple times until it becomes firm. This is going to reset the pistons to compensate for the new brake pads. And then lastly, double check the reservoir one more time after resetting those pistons, just to make sure that we are still full. If everything looks good, we are ready for a test drive. At the onset of the test drive, I like to press the brakes firmly several times as I'm backing up out of the driveway. If everything sounds good, I'll do a couple trips around the block.